combinations. So you'd be given this question. You flip a coin 5 times. How many different orders of 2 heads and 3 tails can occur? Now, you've been given a pretty interesting formula here. And I'll just pull these upwards so we have some room. There's 2 formulas here. The one on the left, this is the formula for a combination. Let's call it, label it number 1. Okay, this is our combinations formula. This is kind of like a type of fundamental counting principle formula. Okay, but this is a combination question. So the way that it's been explained to you is you take the total number of times, that's your A value, and then your B value is, our 2 heads, and our C value is our 3 tails, okay? And they've given you 3 different variables. But really, there's only 2 pieces of information we need here, okay? Because we only need the total number of flips, and either us getting 2 heads or 3 tails. And the reason being for that, the reason being for that is because if you get 2 heads, the only other option is 3 tails. Or if you're getting 3 tails, the only other option is 2 heads. So this is kind of like redundant information. We don't need this part, or we focus on this and we don't need that part. Okay. So really what it's asking in terms of a combination, let's use this again. Colors are all off here. Our total number of times will be our n value. Okay. So this is our n. And we'll just say that red will be our R. We're looking for 2 heads, okay? So that would be our R value. So we have 5 choose, it's annoying when they'll show up there. 5 choose 2, okay? And the formula ends up being 5 factorial over 5 subtract 2. All of that is factorial, so I kind of wrote that backwards. That should be outside of this, not inside. And then times r factorial, and r factorial is 2, okay? And I'm going to relate this to here. So it made sense when we had our A value was the total attempts. Yeah, there's 5 attempts. Our C value, let's change that. Let's do a different color. Our C value is the number of tails, okay? Actually, no. Let's make that our C value. That's not true. Let's do it this way. Our C value is going to be the number of heads. So there are 2 heads. Okay. And then 5 subtract 2. Well, that ends up being 3. Okay. So we still have 5 factorial over 3 factorial times 2 factorial, which is essentially what our tails were. So they just kind of wrote the formula differently, but there is no real difference here. This is still the combination formula. They've just kind of gone deeper into it. Okay, so they give you a whole new formula when really you only need to know the combinations. So we do our combinations here, and of what we have, we go and work this out. 5 factorial is the same as writing 5 by 4 by 3 by 2 by 1. Okay, and all of that will be over 3 by 2 by 1. It's 3 factorial times 2 by 1. Okay. Now our 3, 2, 1, we can kind of eliminate those because this is all multiplication. These will drop off. And really what we're left with is 5 times 4, which is 20, over 2 times 1 is 2. So the answer is 10. There are 10 ways to get 2 heads. Okay. Now we did that for 2 heads, but what if we decided to choose for 3 tails? Well, I'll show you how that ends up being the exact same formula. If we say 5 choose 3, okay, we still have 5 factorial. This time we do 5 subtract 3, and we find the factorial of that, times 3 factorial. Okay, so these 2 numbers are different, but when we work it out to the next step, we get 5 factorial over 2 factorial times 3 factorial, and because it's multiplication, there is no difference here. It's the exact same question. And I actually went and made an Excel sheet for us so we can kind of see. Here are all our possible options. There are 32 total ways you could flip the coin. If you do 5 flips, there are 32 total outcomes. And we highlighted the ones where you get 2 tails or you get 3 heads, depending on what you're looking for. It's all the same. And we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 options. So this is really a combinations question, even though they tried to pose it, I guess, as a fundamental counting principle question.